Hello everybody, this is Algebra 2 6.1. Here's the contact information here. Let's get to the lesson, okay? 6.1, use combinations and the binomial theorem. This is a class worksheet here. You got 26 points on part 1 here and then 5 points of notes. This is the bell work for students. Come on in to the classroom, or for homeschoolers, this is your warm-up here. Describe what happens to the graph of the function as x increases. So you were referring to up here. And find the average rate of change of the function over the given intervals for here. If you need more room, students, attach a sheet here and staple it. As x increases, the graph of f of x rises more. Well, wait a minute, I'm giving you an answer here. This is an answer PowerPoint. And then here's the average rate of change for these. On these intervals here, it shows the average slope of this exponential here. Okay, page 1 of our lesson here, use combinations in the binomial theorem. You use the counting principle and permutations. You will use combinations in the binomial theorem, so you can find ways to form a set. As example 2. You have learned that order is important. This is classwork, page 2 on your class worksheet. For some counting problems, for other counting problems, order is not important. For instance, if you purchase a package of trading cards, the order of the cards inside the package is not important. A combination, here's vocab, is a selection of R objects from a group of N objects where the order is not important. So that was your definition for here. This goes in your notebook, students, page 3, 6.1. Classwork, page 4. Combinations of N objects taken R at a time. The number of combinations taken from a group of distinct objects is denoted by NCR and is given by this formula here. N choose R, or NCR, equals N factorial over quantity N minus R factorial times R factorial. This is an important formula here for figuring a combination taking N objects from R at a time. Classwork, page 5. Find combinations. Cards, a standard deck, 52 playing cards. 4 suits, or 13 different cards for each suit. If the order in which cards are dealt is not important, how many different 5-card hands are possible? That's a great question. The number of ways to choose 5 cards from a deck of 52 cards is right here. 52 choose 5 equals 52 factorial over 47 factorial times 5 factorial. And we come with this number here. So that's the amount of 5-card hands from a deck of 52. That'd be the way to figure it, by using the formula for combination. Page 6 of classwork, 6.1. In how many 5-card hands are all 5 cards of the same color now? For all 5 cards to be the same color, you need to choose one of the 2 colors, and then 5 of the 26 cards in that color here. So the number of possible hands, here are your different colors here. Standard 52 card deck contains these different denominations here of cards. And then so we have a compound combination here. 2 choose 1 times 26 choose 5. And then after this multiplication here, We have this number here by using factorial multiplication here. These cancel here. So we have these numbers here multiplied times each other over 5 factorial, and we get this number right here for a hand to have one color and then 5 of the 26 cards in that color. And order is not important. To use your combination formula. Find a number of combinations. This is for you students. Find a number of combinations. And this is page 7 of your class worksheet here. So 8 choose 3 would be 8 factorial over 5 factorial times 3 factorial. And then we expand our factorial out here, then we cancel. That's one way of doing it. Or you could use your calculator for this. But this is one way to do it, by hand. And that quotient gives us 56. Into our homework here, we have 104 points on our homework. And we had 5 points on our note-taking. Find a number of combinations. You can use calculator or do it by hand, up to you. Same thing here, page 2 of the homework, 15 points. Same thing here, page 3 on the homework, 10 points. Describe and correct these. This is up to you, students. 16 points here. And then card hands, back to the card hands. Find a number of possible 5 card hands that contain the cards specified. The cards are taken from a standard 52 card deck. So figure that one out. Page 5 on your homework. 4 kings and 1 other card. And then card hands, same thing here. 52 card deck. Page 6 on your homework. 16 points. And then again a 52 card deck. At most 1 queen, at least 1 spade. These are worded a little bit differently here. You might have to wait to part 2. I don't think we did these in part 1, but go ahead and give it a shot, and part 2 of this lesson will cover the at least and the at most. You can wait until then to do this for your homework. Thank you very much. Here's my contact email. If you have questions about PowerPoints and videos, thank you.